Welcome to this video. So I'm back again with more tips on how to increase your GCSE Science grade. We're going to look at an underrated tip that is not usually talked about to really help you access that higher grade. So I'm here in the AQA GCSE Combined Science website. If you are doing GCSE Triple Science, then please go to the specific GCSE you want to look at, so GCSE Biology or GCSE Chemistry or Physics. With GCSE Combined Science, it's just one website with all three sciences contained within one specification. So this is where I'm on. And if you go to Assessment Resources, and what I'm going to do is I'm just going to look at a single paper and show you the best tips. So June 2024, I've selected, and then I am going to go for, you can select the subject that you want. So today, let's have a look at chemistry. So I'm going to go for chemistry paper 1 higher. So this is the code for it. And I want to make sure that I'm looking at examiner reports, mark schemes, and question papers. So if we click on the first one, which is the paper 1, if we just start off with that, and the example that I'm going to use as well. So this is paper 1, the mark scheme is here, and the examiner's report is here as well. Now I have clicked on all of these and opened them up separately. So here's the question paper. And we have got the mark scheme over here as well. And then also the examiner report, which is here as well. Now I'm going to tell you about the examiner report. So the examiner report tells you how the cohort did in that exam. So this paper right here, the whole country will have done this nationally. And essentially, what the examiner report does is they look at everybody's results or a large sample of results. I'm not sure if it's how big the sample is, but it would be a very big sample of students, and they look at um, what did they write in the exam, and what were their common misconceptions, what were the strengths and what were the weaknesses of that cohort. Now, why would that even be important? Because it can tell you a lot um, about essentially what are the common misconceptions, what are things, common mistakes that you could potentially make in future exams, and how to avoid this. So we're going to look at an example today of question 2. So this one here I thought would be a very good example to talk about. And we're going to just go to the mark scheme as well and look at that as well. So I'm going to go to question 2. And then the examiner report, I'm going to go down to question 2 as well. I'm just going to click here. So it's going to start off here, I think. Here we go. So let's have a look at this question. A student prepared copper sulfate by reacting an acid with excess copper carbonate. Figure 3 shows the first 2 stages in the preparation of copper sulfate. So here's stage 1, where they're adding copper carbonate to a beaker. It has an acid. They have not specified which type of acid it is. And then stage 2 is the copper sulfate solution. So from this beaker where we reacted this together, that same beaker is being filtered using a filter, a funnel and some filter paper most likely, and then but they haven't labeled that. And then that solution is dripping into copper sulfate, so they're removing any unreacted copper carbonate as well. So the first question that they ask you, it's a multiple choice. What is the formula of the acid used to prepare copper sulfate? So the clue for this is in the question. It was copper carbonate. It's reacting with some type of acid. Now this can be hydrochloric, it can be nitric acid, So this is nitric acid, and it can be sulfuric acid. Now, if we have a sulfate being formed, that means the copper must have reacted with some sort of sulfur in that reaction. So I know for sure that this sulfur is right here in sulfuric acid to form copper sulfate. So I will know that this is the correct answer. So let's have a look at the mark scheme. It is H2SO4. And what the examiner report tells us is that H2SO4, 70% of students answered correctly, and hydrochloric acid was the most common incorrect response. Maybe because it's such a common acid in required practicals and all of that, and students would have used hydrochloric acid a lot, so maybe that's why they just assumed that this is it, but they did not look at the details in the answer, and in the question itself it says forms copper sulfate. So that's what the examiner report told us. Let's have a look at a few further questions and see how the examiner report helps us. So 2.2, why is excess copper carbonate used in stage 1? So they put it here in excess so that look at the second one. What is the difference there in that? So you've got the reacted bit, but you've also got unreacted copper carbonate. Now, how has it even reached the stage where it's unreacted? That is because it cannot react anymore, and all of the solution has now reacted. So the answer for this one should have been so that all of the acid reacts. So you know here that all of the acid will have reacted, and therefore adding more after it has all reacted is going to leave some residue at the bottom that is not going to react anymore, because the whole reaction is done. All of the molecules of the acid have reacted. So that's what you have to say. So all of the acid reacts. They have also allowed you to say, so all the acid is used up. Now, let's go on to 2.3. So let's go down here. So beaker N contained copper sulfate solution. Describe how the student could produce copper sulfate crystals from the copper sulfate solution in beaker N. So this is a required practical in science. If you have done this, you will know what the next step is. So the first step here, they have already shown you filtration. The next step is crystallization. Now, how do you do that? You have to heat the solution up so that all of that, essentially all of the remaining liquid evaporates and leaves crystals behind. So you let it cool down afterwards for it to crystallize. So that is what this required practical is about. Let's have a look at the answer. So heat the solution to remove some of the water and leave it to cool and crystallize. So heat the solution and then leave it to cool down to crystallize. So those are the two marks in this. Ignore references to filtration. Why is that? Because it's already been shown in the figure. It means the student has already done it, or whoever's doing the practical here in this case has already done it. Okay, so that's how we know. Now let's have a look at the examiner report, see what we've missed. So 2.2, why is excess used? That is to ensure all of the acid reacts. More than a quarter of students answered this correctly. So this means about 75% of students did not answer it correctly. They did not know why we add excess. Why do we add extra? So common incorrect responses included that copper carbonate needs to dissolve to make sure that all of the copper carbonate reacted rather than the acid to get the most product, so everything had reacted in terms of rate of reaction. In responses, it refers to copper carbonate. So saying it does not get the mark. So in this case, look at what the student has answered. So that we know we have added enough of it to have fully reacted. It in the question, why is excess copper carbonate used? This is not what they should have said, okay? So they should have said so that all the acid reacts, okay? Because we obviously wanted to make sure all of this acid has reacted, and that is exactly what's happened here. We've got excess amount of this. So they shouldn't have said it, because in the question that would be referring to copper carbonate and they would get the question wrong. So that's what they're talking about here. That the person got it wrong because it's not creditworthy as it refers to copper carbonate, not the acid. The second response gains a mark as they said acid is the one that is fully neutralized or reacted. So that is the equivalent of saying the acid. They should have said that, okay, explicitly. So this just showed you in this examiner report, just shows us that saying it in your answer, not specifying what has fully reacted, could potentially make you get no marks. So it could be that the student knew what it meant, like they were referring to the acid, but it could be that they didn't pay attention to the question. Why is excess copper carbonate used? So when they say it, it's assumed that they're referring to copper carbonate. Okay, the next one we have already looked at. So beaker N contained the copper sulfate solution. So the method would work if filtration was carried out immediately before or after heating, so was ignored in any response. Just over a third of students gained both marks. So not everyone gained it, just a third gained full marks. Okay, so in this case, let's have a look at these answers. The student could heat it with a Bunsen burner until it boils and then pour it out on a tray. So the first response gains the first mark, which is to heat the solution, but they haven't said to leave it to cool down or leave it to crystallize. So they have not said that in here. They just said pour it out on a tray, but they're just saying what the action is. They're not saying what's the reason for it. So in this case, the second question gets full marks. By filtering it and then heating the solution up, so this is ignored because filtering, there should be no reference to it. It says ignore it. So it's not necessarily wrong, but we just ignore it. Leaving it to cool for 24 hours and then putting it dry as patting it dry as crystals have formed. So heating the solution up is 1 mark. Leaving it to cool and crystallize is the second mark. So in this case, they have received the full marks here. Okay, so you can see how important the wording is in your answer. Okay, let's have a look at the next question. So in this one here, this is still question 2, so it's just continuing on. Now, a student investigated the thermal decomposition of copper carbonate. Copper carbonate decomposes to form 2 products. So we've got copper carbonate here being heated, and we are using the heat to accelerate the thermal decomposition. Now, in this case, this is a method, so they add this here and then they heat the test tube, record the mass, so you can see this whole table here. Now, I'm not going to do this one because I've already done a video on how to plot a graph, and I will just link that video, an info card above this section, so you can have a look at how to plot a graph, and how to do your line of best fit and all of that. So that's part of the mark scheme. I'm going to go on to the next question, which is 2.5. So why does the mass of contents of the test tube decrease in mass when copper carbonate is thermally decomposed? So there must be something escaping from here. Now, when copper carbonate reacts with oxygen, it forms carbon dioxide. So that is a gas. Carbon dioxide is a gas and it's let off like that. So essentially what is happening here is that you have copper oxide being formed and then carbon dioxide is being let out of here. So this mass 1.2 is going to go down, and that is what we see happening. I think, is it over here? Mass of copper carbonate before heating in grams. So you can see that happening here where it's going from 1.2, it's going to 0.8. When it's 2.4, it's going to 1.7. So essentially for every single one, it's going down after you've heated it up. So in this case, they're just asking you why. So you just have to say that gas escapes from the test tube. Or you can say that carbon dioxide is being formed and escaping from this test tube. So let's have a look at the mark scheme. A gas escapes, and that's all you have to say. This is just, you don't have to say this to get a mark. So you can just say gas escapes, and that is a mark from the test tube. Or you can say carbon dioxide escapes from the test tube. Okay, so let's have a look at the examiner report one last time and see what was the answer. So in this case, 2.5, they have said, investigation of mass changes using various apparatus is an opportunity for skill development in the specification. So for example, thermal decomposition of metal carbonates. This was not well answered on this paper, and many students incorrectly referred to evaporation or gave answers such as some of it escapes, which is insufficient. Some recognized that a gas is made, but they needed to say that it escapes. So they knew that there was a gas being made. They didn't say it escapes. So they said here to explain the decrease in mass. So essentially, this is one of the things that students were very weak on because they have said, explicitly stated, this was not well answered on the paper. So that tells you essentially what we've done in this question is we've gone over what are the weaker areas, what are some of the stronger areas in answering questions, and it really does give you an insight into what are common mistakes to come across and what should you not do in the real thing. So for example, you can go on and study thermal decompositions of metal carbonates. It would have come up in the specification and you have to know it. So if this is something that you don't know well, you can focus on this as your area. This is also good for students who don't know yet what their weaker area is, so that you can perhaps read some of these. So if you don't know what weaker areas or weaker topics you have right now, then you can go into examiner reports for past paper exam questions and have a look. What do students struggle with? Because that could be what you struggle with as well. It's not always the case, but a lot of times it can be. For example, here, it was not well answered on the paper for pretty much everyone. So I hope that this was useful. This is something to do if you really want to achieve that higher grade, where you want to make sure that any misconceptions, any common mistakes are not known about. And then you can study these and make sure that you don't do these same mistakes when it comes to exam skills and exam technique and applying your knowledge as well. So it's a good way to strengthen and consolidate that knowledge. Now, I'm just gonna go over to and I'm going to be talking about this GCSE Science booster that is available during February half term. It will go over GCSE Biology content, chemistry, and also physics for every single one of those days, and it's there to improve exam skills and knowledge in general. There are also other classes being offered on other dates as well. So I really do hope that this video was useful. Have a look at my other videos on exam skills and all of that, which should hopefully help bring your grade up. Thank you so much for watching and see you in the next video.